when someone asks, can you tell me the traffic flow? Okay, let's say when you do a google.com, when you do a google.com on your Chrome browser or whatever browser, what is basically happening? Okay, so first thing first, on your PC, you type google.com. Now on your PC, you have something called as a memory, or basically called as a cache memory. Cache memory saves all the previously searched or previously visited websites and their respective IP addresses. Okay, so let's say you visited Facebook, you visited Netflix, you visited Google, or you visited some other website. So your PC keeps a PC keeps a data, or your PC keeps a note of all the websites that you visited and the IP addresses of those websites into your cache memory. Now let's say your PC does not have the history of google.com in its cache memory. So basically the IP address, okay, the IP address of google.com is not there, right? It's not there. Now, what is going to happen? Your PC is going to send a DNS query, a DNS query. Okay, let me stop this. If your IP address is not present in the cache memory, first, a DNS query is sent to DNS server. Okay, we know the DNS means domain name server, which basically keeps the record of all the websites and its respective IP address. Right now, it sends a DNS. I'm not going in depth about DNS because, to be very honest, even I don't know much about DNS. Right, so that is why I'm not going in depth about it. All I know, it sends a DNS query to the DNS server asking, does it know the IP address? Does it know the IP address for google.com? Okay. Second, it gets a DNS reply. In the DNS reply, the DNS server is saying, yes, it knows the IP address of Google server. Let's assume that the IP address is 8.8.8.8. Assume that. Okay. Now, so when you do a google.com, your PC did not know the IP address of google.com. Now, after the DNS query, it knows the IP address of the Google server, Google or google.com. Right? Then, what it does, it first tries to create. It first checks, first of all, it checks if this 8.8.8.8 is it in the same network as the PC or not. Meaning that whatever IP address that your PC has, and obviously this 8.8.8.8 is a public IP address. It's not a private IP address. So obviously your PC, which will have a private IP address, okay, let's say 192.168.1.3. This is a private IP address. So your PC checks whatever server you're trying to reach, are they in the same subnet or not? Okay, so obviously 192 and 8.8.8.8 are completely different networks. Okay, are completely different networks, right? So first thing, what your PC tries to do is it tries to create a TCP session, because we are going for a google.com. First, it tries to create a TCP session. In the TCP session, right, it tries to look for the source port that is the PC's port number, and a destination port. Destination port for 8.8.8.8, which is basically port number 80, a very well-known port number for 8.8.8.8 or WWW, World Wide Web, Internet, right? Then what it does, it creates a layer 3 header with destination IP as 8.8.8.8, source IP as 192.168.1.3, right? Then it creates a layer 2 packet, where it tries to look for the destination MAC address of 8.8.8.8, and it cannot find. Source MAC address over here, it is 1111, for example. Okay, in layer 2, it creates this packet. Now it does not know the destination MAC, so obviously it needs to create an ARP request. Okay, however, it knows that these two are completely different networks. They are different network. So even if the PC tries to create an ARP towards 8.8.8.8, it cannot reach there because they both are different networks. Your ARP will reach only those devices which are in the same network. Okay, so if this was 192, the ARP would have reached Google server. But this is not 192. This is 8.8.8.8, and they are completely different networks. So ARP is not going to be generated by the PC first of all. Okay, ARP not generated. ARP is generated, but it will not reach the server. So in this case, what is going to happen? ARP is generated by the PC. It is also sent. Okay, fifth, ARP created. ARP is created. ARP is also sent. Is also sent. But who replies for this ARP request? It is the default gateway router. Your default gateway router will respond for ARP request. This is basically called as your proxy ARP. Someone else who is not the destination IP is responding to the ARP. It is called as proxy ARP. Now, how proxy ARP is working, let's check that. So your PC is sending an ARP request. This is your default gateway router, and here is your server. It created an ARP for 8.8.8.8. It is received by router. Router knows 8.8.8.8 and 192 are completely different network, and this ARP request cannot be sent to the server. Okay, so what router does is it sends back an ARP response with destination MAC of the router itself. So how is it working? Let's check. So here in ARP packet, layer 3 is source IP of 192, destination IP of 8.8.8.8, right? Source MAC of PC number 1. Destination MAC, we are checking the ARP packet. Okay, destination MAC is obviously 00000. Okay, in layer 2, source MAC is PC1's MAC address. Destination MAC is all F. Okay, now this packet is sent to the default gateway router. The default gateway router knows it cannot forward it to the server. So the default gateway router responds to this ARP with its own MAC address. So now in the source MAC address over here, it is R1's MAC address. Destination MAC is PC1's MAC address. Okay, here in the ARP response, source IP is 8.8.8.8. It keeps the source IP as 8.8.8.8. Destination as 192. Source MAC as its own MAC address. Destination MAC as PC1's MAC. And it sends back this ARP response to the PC. So now PC, instead of getting the MAC address of 8.8.8.8, it gets the MAC address of the default gateway router. So what happens? This packet over here is now complete, but it is complete with the MAC address of the default gateway router, that is R1. Clear? Any question till here?
No, sir.
No. Hey, hi, Srinivas. Any question? I don't know where you joined and how far.
No,
How
due
did
to
you
some reasons I joined late. Okay. I
Okay.
got it. This is important one. This also like how to this is regarding when you type something, how process, right?
Yeah,
How
yeah.
it will.
When you type
Okay.
google.com, for example.
Yeah. Okay.
Okay. So here, now the packet is complete with the default gateway router's MAC address. Right. Now, once that is complete, as I said, it is trying to create a TCP connectivity. Your PC will try to create a TCP connectivity. But for the TCP connectivity to happen, as I said, TCP is a layer 4 data. But for a layer 4 data, layer 3 data should be complete. Layer 2 data should also be complete. So to complete layer 3 data, it got this information. So then it tries to create the layer 2 data. When it is trying to create a layer 2 data, it comes to know that destination MAC is not present. There it creates an ARP. With that ARP, now we know the process. We got the proxy ARP. Okay, we got the proxy ARP. Now let's see what is happening. So your PC, it has the source IP of 192.168.1.3, destination IP of 8.8.8.8, source MAC as its own MAC address, PC1's MAC address, or whatever the MAC address is, right? And the destination MAC. Here, the destination MAC is R1's MAC address. Okay. Now what it does with all this information, it tries to create a TCP connectivity. Okay, this is your
Like so one question, like not small question, like
yeah.
Like they will ask like this only when you type something, they will not give exact browser, right? Like you have to type google.com, then what will happen like that? Or otherwise they will ask like when you type something on the web browser.
Yeah,
So
what happens? Yeah, that's what they ask. Basically, what they ask is when you type some website name, what is happening? That's what they ask.
Okay. Yeah.
So in layer 2, source MAC is PC1's MAC address. Destination MAC is R1 or the default gateway router's MAC address. In layer 3, you have the source IP as 192 address, destination IP as the Google server's IP address. Then in layer 4, because you need to create a TCP connectivity with the Google server, you will have a source port. We know that the source port is created at random, any random port from 0 till 65535. Any random port can be used as a source port. Okay. So as I said, between 0 and 65535, it can use any port number, random port number. Okay. Your PC. Destination port is going to be a well-known port number because 8.8.8 is internet site. For internet port numbers, a well-known port number is used, that is port number 80. Okay. Now this TCP connectivity is sent to the router. Router will read all this information. It reads source MAC address as PC1's MAC address, destination MAC is its own MAC address. It reads the type field, it opens the layer 3 header where it sees the source IP as PC1's IP, destination IP as Google's IP address. Here also it reads the protocol field. In the protocol field, it sees TCP. So it opens the TCP header, right? And it reads the destination number 80. Now what happens? Your router is going to create a TCP connect. It is going to send a TCP three-way handshake connectivity. A three-way handshake connectivity, which is basically started by your PC. The three-way handshake. So in that three-way handshake, all this is happening. In that three-way handshake, your source IP is also needed, your source MAC, destination MAC, all that information is needed. This three-way handshake is basically sent to the router. The router is then forwarding that three-way handshake to the Google server. The Google server, after reading all this information, is basically responding back to the router. The router is then forwarding that response to PC number 1. And this is how your your traffic flow is happening. Any question, Vivek, Srinivas?
Like, so router is there, right? Like it works at layer 3. So it can see that layer 4 thing actually when it received from the PC1.
BGP works on layer 4 also, right? BGP is a layer 7 device.
Yes, correct.
Yeah.
I have
So,
a little bit doubt. Like router, it works at
yeah.
something. It can only
See,
it will forward based on source and destination something. Yeah.
no. See, it's a router basically works on IP, okay, which is layer 3. But that does not mean it cannot understand layer 4 information or layer 5 or layer 6 or layer 7. BGP is a layer 7 protocol. It uses TCP, which is at layer 4.
Yes.
That means a router understands TCP, which is layer 4 information. And it understands BGP, which is a layer 7 protocol.
Yeah. Okay. Yes. Got it.
Right. So merely here what is happening is router is just forwarding the TCP connection towards Google server. It's just merely forwarding that request to the Google server, and the response that is coming back from the Google server, it is forwarding that to the PC. So let me again go back to the traffic flow. Okay, let me write down that here. Okay, so the first thing when you type google.com, let's say you type google.com, what is happening? Okay, so your PC is looking in the cache memory. It is looking in the cache memory for the IP address of google.com. Okay, if it is present, okay, no problem. But if it is not present in the cache memory, the IP address of google.com is not present, what has happened? Second, your PC will send a DNS request. PC will send a DNS request to the DNS server. Okay, and it will receive the IP address from the DNS server. It will receive IP of google.com. I'm just writing Google as G. Okay, now the IP is received. The IP address of the the IP address of the Google server is received. So once the IP address of the Google server is received, the PC tries to create a TCP connection. Okay, TCP connectivity. A TCP connectivity with Google server. When trying to create a TCP connectivity with the Google server, it creates the layer 4 packet, right? Which is your TCP segment. In that TCP segment, it creates the destination port of 80, source port that is random, any random port number. Okay. Then it creates a layer 3 because this TCP connectivity, if it wants to be reached, if it is set to be sent towards the Google server, a layer 3 packet needs to be created. So in the layer 3 packet, it creates the destination IP of 8.8.8.8, right? Source IP of PC1, right? Then it creates a layer 2 header. In the layer 2 header, it sees the destination map. It does not know the destination map, right? And the source MAC is going to be PC1's MAC address. Because it does not know the destination MAC, it creates an ARP request. ARP request is created. Okay. Now, this ARP request, as I said, can only be sent inside the same network. It cannot be sent outside the network. Okay. However, the ARP request is created, right? ARP request is sent. It is sent and it is received by your default gateway router. Okay, it is received by your default gateway router. Now your default gateway router, it knows that this ARP request cannot be forwarded to 8.8.8.8 because PC1 and the Google server, they do not belong to the same network. So the ARP request cannot be forwarded. So a proxy ARP is sent back to the PC, where source IP is the default gateway router's IP address. Destination IP is PC, not default gateway router's IP address, sorry. The source IP is 8.8.8.8. It's a proxy ARP. We know that, in colleges, we used to give proxy attendance for our friends, etc. Similarly, here, the default gateway router is acting as the Google server. That is why the source IP is 8.8.8. Destination IP is PC1. Source IP is the default gateway routers, not source IP, source MAC. Source MAC is default gateway routers, source MAC address. Destination MAC is PC1's MAC address. This is your proxy ARP. Now, with the proxy ARP, your layer 2 information is complete, where it has the destination MAC of default gateway router, source MAC of itself. In layer 3, it has the source IP of PC number 1, destination IP of the Google server, and in the layer 4, which is your TCP header, right? Source port, as I said, any random port, and the destination port is port number 80. With all this information, this data is forwarded. Okay, now this TCP connectivity, right? The TCP connectivity is received by your default gateway router. The default gateway router forwards it to the Google server. The Google server then responds back for that TCP connectivity. That response is received by the default gateway router and it is then forwarded to your PC number 1. And with this TCP connectivity with your Google server, now the data transfer can happen between your PC and the Google server. So what happens? Your PC starts to ask, like, when you do a Google server, let me open a website. Okay. So after your TCP connection has happened, what are the information that your PC is sending or asking? It is basically asking these things: the logo, the sign in, the background, get started. All this information is being sent and received from the Netflix server. It can be Netflix, it can be Facebook, anything. If it is Facebook, let's say, okay, so all this information, this Facebook's logo, okay, this Facebook login page, create new account, all these things that you see at the bottom of the screen, all that information is sent by the Facebook server to your PC after your TCP connection has happened. And once all that data transfer takes place, your screen looks like this. The TCP connection is not over. The TCP connection is still present between my PC and the Facebook server over here. It is still present. When does the TCP connection gets over? When I close this window. When I close this window, the TCP connectivity that has happened over here between my PC and the Facebook server or the Google server breaks when I close the window. Clear?
Yes, yes, like super. I got a clarity, but one doubt like so now TCP once it is established na, between client and server na. So next when I click something on that Facebook or something logged into that and I click on that any image or something, again transfer will like both sides will be like our side also will send data and other side also will get a data, sir. Like both sides will be transfer will be done or one side only.
Both sides. When you click, let's say when you click login, login is a kind of a request, right? I want to log in. After when you click login, the next page should open.
Okay.
So your PC is sending the login request. It goes to the TCP, it goes to the Facebook server. Facebook server sends back the response to it.
Okay. Yes.
And when your PC receives that response, it opens the next page.
Yes. Yes. Understood. Thank you.